Welcome to the live webinar, Applying Real-Time SQL Changes in Your Hazelcast Data Grid. I'm Andrea from Hazelcast, and I'd like to introduce you to our presenter, Per-Åke Minberg, founder and CTO of Hazelcast partner Speedment AB. He will be presenting on how easily the Speedment SQL reflector can be installed on a SQL database and seamlessly integrated with Hazelcast to gain the most benefit from the two technologies. We'd love for you to ask questions, and please do so using the question box in the control panel. We'll address those at the end of the presentation. I'm going to go ahead and turn it over to Per-Åke now.
So, hello everybody, thanks for the presentation. In this presentation, I will talk about how to use Speedment and Hazelcast together so that you will be able to track any changes in the relational database and feed that into Hazelcast maps, regardless of how the database is changed. Now, Speedment is a company that's originally from Sweden, as my accent might reveal, but we are also located in Palo Alto in California since last year, just about 2 miles away from Hazelcast headquarters. Now, Speedment develops and markets a platform that allows our customers to handle real-time big data queries instantly. As opposed to many NoSQL solutions, our framework allows customers to retain their original existing relational database and still gain the benefits of this new technology. We call that concept Yes SQL. So in our world, the customer already has a relational database that the customer do not want or cannot replace. And data lives in a proven and safe environment like Oracle or Postgres, but can also be retrieved super fast via other APIs. Speedment provides something we categorize as an accelerated ORM. The ORM is short for Object Relational Mapping. A well-known ORM within the Java community is Hibernate. I'm sure you know about that. And Hibernate provides a view of the relational database using Java objects and isolates the programmer so he or she can remain more or less in an object-oriented world. Okay, so we were talking about Hibernate, and the problem with Hibernate was that it actually made access to data slower. And another problem with Hibernate is that you have to write some SQL-like code. So with Speedment, we remove those drawbacks. Speedment stores all data in a native in-memory graph-like structure, or it can store data in Hazelcast maps. This allows data to be accessed fast and in a purely object-oriented fashion. And with Hazelcast, data can be scaled out on a large number of nodes, and you can benefit from all the other good things provided with the Hazelcast framework. So in this presentation, I will go through the steps on how to set up a complete environment that replicates any change in an underlying relational database all the way out to the Hazelcast maps. Okay, but before we start, I would like to say that I did this implementation myself, but I'm not really a super Hazelcast expert. And also I'm doing the presentation on another computer, not my own development computer. So I'm going to show you a video after a while, and I will not be able to show you everything in real time. So what can Hazelcast do today? Well, Hazelcast does already provide persistence by allowing to load and store distributed map entries with a persistent data store, for example, a relational database. And that you can use that if you use Hazelcast map store and map loader interface. So if you, for example, put a new entry in a map, it can also be automatically saved in the corresponding relational database table. And if you remove that later, if you later remove that entry, it's also removed from the database. And all those things are handled by Hazelcast automatically once you have provided a map store factory. And I think that's a nice concept. It provides automatic loading and initial loading of the Hazelcast map too, if you make a restart. Well, that's good in an environment where you have full control and only alter the map via the Hazelcast APIs. But it doesn't help you if you have a third-party application that's making changes directly to the underlying database. And that leads us to the shared database challenge. So you see in the picture here, you have Hazelcast apps. And if you go through Hazelcast, well, it's okay. But what if you have other applications from the side? Maybe you have scripts or back office application, or you have harvesters or whatever out there, old web applications, back office things. So here we have the problem that if you have data in your Hazelcast map and a third-party application is making changes, for example, by changing a record, you will end up with a Hazelcast map containing stale data. So what can you do about that? Of course, you can always expire data from the map after a while. So when you expire, you will get the data again from the database fresh. And well, that can be great in some cases, but it's inefficient. And you probably will expire a lot of perfectly valid records. So if you just have one record after changed, and you have 1 million records in your map, you will eventually expire all those million records just to get that single record fresh in the map. And that's not very efficient. Data may be stale between refreshes, so you will end up in an unwanted situation where you have to choose both from staleness and inefficiency. Another way of doing it is to perform a round-robin-like refresh of data. That will lead to the same problem, of course, as the other solution. You will get latency because you cannot refresh all your data as often that you perhaps like due to database capacity restraints, for example. And if the number of changes to the database is low, you will end up refreshing records that are already up to date. But there is also a more fundamental problem with this solution, and that is that you will see updates in pretty much random order as they're being expired or refreshed. The underlying database transactions will not be reflected. So if you do a database transaction update, where you perhaps change several records, then they will be visible at different times in the Hazelcast map. And that will create an invalid and inconsistent view on the underlying database. And this is, of course, not related to Hazelcast as such. It's just a drawback of the method. So what can you do about that? Well, this is where Speedment comes in. So the combination with Speedment and Hazelcast, you will get event-driven updates of the maps whenever a change to the database is made by a third-party application. The events are fast, of course, but because we want to have as little latency as possible between database update and Hazelcast map updates. And it's also very efficient, meaning that they contain just the changes records and nothing more. And also the solution is transaction safe, so that any SQL transaction changed to one or several tables in the underlying database are executed as a single atomic transaction, all the way out to the Hazelcast maps. So in that way, we can provide a consistent view of the relational data in the Hazelcast maps at all times. And there are competitors providing this, for example, Oracle, with Oracle Database and Oracle Coherence, Golden Gate Hot Cache, but I think that they have a narrow price point, of course, and then it will only work with Oracle products. So this is another view of it. So if you perform like insert, updates, or deletes, the database will trigger that, and I will send it to Speedment. That in turn will update the Hazelcast data grid. So this is one example. Here we have a Hazelcast map like this. That in this case contains 300,000 records, and then if you insert another record with Georgie here, it will automatically get into that map, and when you get it, you will get that out of the map without doing anything. It's just handled in the background. Same thing with updates. Perhaps we rename Georgie to Georgie 2, and then that is updated automatically. So you get the same, using the same key, you get Georgie 2. And if we delete it from the database, well, then if you get from the map, it doesn't contain anything. It's just null. And as I said, it will work with transactions. So if you start a transaction and you update the employee name or you update the salary, and then you commit the changes, it will be conveyed out to the Hazelcast maps, either both of them or none of them until it's done. So you will not end up in the situation where one map is updated and not the other. So they will be updated atomically. So how do you install? It's very easy. You download the software, unzip the distribution file, and then there is start script in the bin directory. So it works like any other software. So what does it do then? Well, it generates codes. So you get a lot of stuff when you start the Speedment thing. And Speedment is actually divided into two parts. Part one is the GUI, that is examining the database structure and generate codes. And part two, that's the runtime libraries that you need to include in your applications, your Java application. So once the GUI is started, it connects to the underlying database and analyzes its structures, like schemas, tables, columns, indices, primary keys, foreign keys, and other stuff. And using that structure, it generates a number of scripts and Java classes. First thing are database triggers. So Speedment generates 3 database triggers for each selected table. One for insert, one for update and delete respectively. So these triggers together captures any change made to the table, regardless of how the table change is initiated, by a SQL command, by a stored procedure, or even by another trigger. Then it generates a DDL script defining a special trigger log table that exists for each selected relational database. You have one of these tables per database. The trigger log table is used by the triggers to store the table changes. The trigger log table contains, amongst other things, the schema name, table name, primary keys, and timestamp of the change. So if you, for example, update an employee table and change that person's family name, the table's update trigger will create a new row in the trigger log table, indicating that the table employee and the primary key of that affected employee and a timestamp when it was made. And the new row contains more data like this, but well, I will not dig into that right now. And it generates Java POJOs for each selected table. And the POJO or entity, that corresponds to a single row in the table. It is instances of this class that is later to be put in your Hazelcast maps. And it acts like a bridge between the relational and object-oriented world. Now, one interesting thing is you can override and add methods to the generated code if you want to create your own behavior. And these changes, they will be retained if you regenerate your code again. The POJOs implement Hazelcast identified data serial-based interface so that they can be serialized and deserialized efficiently across Hazelcast data grids. Speedment native serialization and deserialization technique coincides to a high degree with Hazelcast concept. So the POJO just contains 2 small methods that acts like an intermediary between them. Then you get something called table manager or data access object, and you get one for each selected table, and they correspond to the table itself, not the rows. So basically this entity will receive the update events from the underlying database. And you can also override methods here to create new behavior and introduce new functionality. Then it will generate Hazelcast serialization factories. And using those factories, objects can be deserialized without the use of reflection. So you will get better performance with that. And Speedment automatically generates a serialization factory for each selected table. So you get that for free. Then we generate a configuration support. And with that, you can just install all the serialization factories directly with one line of code. This is just a convenience class that you can use. Then it generates quite a big thing. It generates a model of the relational database with all the metadata like schemas, tables, etc. And that's something you don't have to care about as a programmer, but it's needed by the other classes to be able to work properly. And then you get transaction support wrappers. Actually, Speedment and Hazelcast transaction are fundamentally the same, and there's a one-to-one mapping between them. But there is a small class that will act as an intermediary between the two frameworks. Basically, it's just the method names that differs. But you don't have to use transaction support if you don't want, because it will affect the Hazelcast map performance, obviously. So you can select that depending on what kind of application you have. So how to use all these new files? First, you have to create the trigger log table and install the triggers in your database. And that's very easy because you only have to run the DDL scripts. You also have to add the dependency to the Speedment core jar in your POM file. So if you use Maven, it's very easy because it's in the Maven central repository. So you only have to add like 7 or 6 lines in the POM file. And then you only have to add 4 lines in your code to get everything rolling. I will come back to that, how that looks. So when you start your project, it will start loading all data from the selected table into the Hazelcast maps. These maps are automatically named after the namespace of the podios. And the key for the maps will be the table's primary key or keys. And different maps, they will load concurrently to reduce start times. And once loaded, Speedment will continuously monitor the trigger table and harvest any changes made to the database using this table. So once a change is detected in the trigger log table, Speedment will pick up that and figure out what to do with the Hazelcast maps. For example, there are some easy cases. If a record is inserted, then of course Speedment will produce a corresponding new podio and put it into the related map. If an existing record is deleted, Speedment will remove it from the map. If an existing record is updated, Speedment will replace the old podio with a new podio in the map. And then there are some more peculiar cases. For example, if an existing record has its primary key updated, Speedment will remove the old mapping for the old primary key, and then we will put a new mapping for the new primary key to the new podio that's resulting there. And there are also some other complicated cases that you will perhaps realize if you give it a thought, but I will leave them out for now. So that's all. So now you can sit back and watch your maps change automatically as the underlying database is changed. Okay. So now I'm going to show you a little bit the demonstration of the concept. But first I want to show how the database and all generated files looks like. In this example, we have an employees table like this, and it's a MySQL table. It's a primary key is employee number. We have birthday, first name, last name, gender, and hire date, various types like this. It's nothing strange there. Okay. And then let's see, after then I run the GUI, I will get a lot of files. So the podio will look like this. That's generated, and as you see, the class fields corresponds directly to the database structure. Of course, you can select what columns you want to include in the GUI. Perhaps you only need a subset of the columns in your application, or perhaps you want to implement your own lazy load fields, or I have left out the accessors here, like getters and setters, native serialization and deserialization, and database communication methods. But you can look for yourself if you try it out. They are pretty straightforward. Under the fields, we see 3 methods that's related to the Hazelcast identified data serial as well. Like this, you get a factor ID, and that's basically delegated from the generated serialization serializable factory like this. You have write data that basically handles an integer of the length and then just calls Speedment's native serialization. And it's the same thing when you read data. You read it, how long it is, and then just reads it using the native serialization, and then use the native Speedment's native deserialization here. It's very small. Okay. Good. So then we come to the manager, table manager, or data access that represents a table. That class has a lot of methods. It's the same here. I will not spend the entire day going through them. But one is interesting. It's called get new object instance, and this one is called by the serialization Hazelcast serialization factory to avoid reflection. So this is just delegated in that. Then we have 2, I would say, important methods here called add and remove. Every time a new record is inserted or changed in the underlying database, that manager's add method will be called with the corresponding podio. Right now, it just calls the support method add Hazelcast that, unsurprisingly adds the podio to the corresponding Hazelcast map. The same is true for remove. That is called whenever a record is changed or removed from the database. So as I said before, you can override the add and remove methods to create your own custom behavior. And we can look at this add Hazelcast method. It just calculates a key from the primary key as a string. And then we see, do we have a transactional map? If we have that, we use that. Otherwise, we use just the native map that we have, like this, or direct map, I would say, and put in the value there. So, and then we have data serial factory, which basically, as I said, called the table manager to create a new instance. That's everything it does. And it also defines the factor ID. It's calculated for each table using a lot of things. So it's basically a hash. And then we have configuration support class that can add all those serialization factories. In this case, I have selected 3 tables. But if you select like 10 or 20, you will get 10 or 20 lines here. It's just a convenience method. So, and then we have transactional support. Well, it's very similar to Hazelcast. So I can show you this one here. As you can see, it's just a name mapping. So in Speedment, the name of the transaction is begin, and in Hazelcast it's begin transaction. So it's really a one-to-one mapping between the transaction that's made there. And you install this one. If you want transaction, you install this Hazelcast transaction factory into the Speedment framework, and it will be automatically used. So that was that. So how do you use it in reality? Well, I'm going to show you a video, but first I want to do it a little bit stepwise like this. So you connect to an existing SQL database, in this case a MySQL database, put in the IP address, username and password, and the schema you want to use. You can add additional schemas here if you want. And then it's automatically analyzed, as you see here. You get DBMS schema, tables, and everything. And then you just push the button, generate code, and it will generate all the code I just told you about. So then you have to use this in your application. So the blue lines here are the ones you have to add. You have to tell that you want to use the serialization factories. You add this support method I told you about before. And then you need to tell Speedment that which Hazelcast instance you want to use. So you do it like this. You just put in the Hazelcast instance here, and then it will automatically pick that up and use that. Then you build the database metadata. It's a one-liner. And once that is done, you have the possibility to change the metadata if you want, customized, and then you load everything from the database and start tracking the database with this one-liner here. And it will continue to supervise the database as long as this thread is alive. And in your application, there's absolutely no change of how you use your maps. So you use them as you are used to do. You get the map and you just get from the map. And it's updated in the background all the time. So you don't need to change anything in your applications. It's just the 4 lines here in your startup code. So now I'm going to show you a video of this. And we just realized that the audio from the video doesn't work. So I have to talk you through here while it's showing. But I think that would be good. So I start here. I hope you see this one. So I'm in the bin directory and I start up the GUI. Starting up, and it looks like this. So I create my new project like this. I call it Hazelcast demo. I have the opportunity to use my own package name for namespace. So I put in something here called Speedment test Hazelcast demo. And then I need to tell the generator, the code generator, where I want my code to be placed. So I have to find that directory. So I'm browsing through here. I'm using NetBeans, so it's in this directory. Of course, you can use any integrated development tool environment. So now I have it here, and I can select what kind of Java version I have. And then it's there, so I'll just add a DBMS. In this case, I have it on my development box. I put in the schema, Hazelcast, and then I'm good to go. So it discovers all the metadata here. So I select every table. I tell them that I don't want any of the tables, but then I go back again and say that, oh yes, I want one table. So I include that, and then I select Hazelcast as a storage engine here. That's important. So that is the one that triggers the Hazelcast integration things. Now I just click on my projects and push the play button, and all my code is generated. So if I have an IDE, I will see everything there from this point. So I switch to my IDE, and you see here is all the generated code. And there's a main method. So now I'm going to code the Hazelcast, and I think you have used Hazelcast quite a lot, so you will recognize what's going on here. I create a config object like this. Then I add to that configuration object, I add all the serialization factories that's been automatically generated for me. Then I create my Hazelcast instance, just as I used to do, like this, using that config. Then I tell the Speedment framework that I want to use this Hazelcast instance. Like this. Then I build up my database metadata like this, that one-liner. And then I start everything off. So this line will trigger a complete load of the underlying tables that I've selected, and all the contents will be put into the Hazelcast map. And then, as long as the thread is alive, that's what I want to wait here, it will supervise the database and pick up any changes and put that into the maps like this. So I start to run it, and it's starting. Now it's finding its space in the Hazelcast environment. And this is the first node, so it takes a while for it to figure out that it's alone out there. So now the Speedment framework is starting, and it starts to load. So now it's loaded like 100 and then 200,000 employees objects, and now it's ready. So now it just sits there and waits. So that's that. So now everything is armed. And I'll switch to my main client, which is basically the same. Let's use client configuration and add serialization factories. Same one-liner as before. But I don't tell the framework to load. This one just uses the maps like this. So it will start to get an employee with number with a certain employee, and it will start to supervise that each second. So you will see Georgie, and I pull in now my SQL command line, and I change that name to Georgie 2 like I showed before. And if you look down there, you will see now it's Georgie 2. My client is printing all the time this particular employee. So I can remove it like this, and then you see it's null. Now it's not in the map anymore. And then I can recreate it as it was from the beginning, and then it will show up there. So now we're back again as we were. So this is how it works, and it doesn't matter how I change the database. It will pick up those changes anyhow. So let's see if I can get away with this one. So that was the video. Good. So what can you do with this? This is good, but perhaps you want to do your own stuff. Maybe you would like to use your own beans instead of those generated, and that's perfectly possible. You can override the add method of the table manager if you want to insert your own POJOs in the Hazelcast map instead of using the generated one. The new add method has to create a new instance of your own POJO class and then copy the fields you want from the generated POJO that's received by the super add method. Then you just insert your own POJO in a Hazelcast map instead. So that's easy. As I told you, if you want to use transaction, you just have to add a single line of code where you provide a Hazelcast transaction handler factory, and then you pick up the database and get the trigger log manager for that and just add that transaction handler. You can have several transaction handlers if you want. And that transaction handler will be used automatically for all transactions. Maybe you want to filter what kind of records you want to have in the map, and that's very easy. You just override again the add method, and perhaps you evaluate the condition that you have decided on, and if that condition is true, you add it to the Hazelcast map. If it's false, you don't. So that's very easy. And maybe you want to react on SQL events. Maybe if you have some table that represents configuration of the application or whatever, then you can just add listeners to the table manager using the add property change listener method, and the listeners will be called in a separate thread as soon as new objects are added or removed from the table manager. So you can do an event-driven SQL pump here if you want to. So that's good. What about performance? I think performance depends mostly on the SQL server and how you've configured and implemented your Hazelcast grid. On my computer, when I run it on smaller POJOs, and I use Speedment in a single Hazelcast instance, I remember to load around 50,000 rows per second per thread. So I can load 1 million rows in 20 seconds using a single thread. And you can also load several tables in parallel. So I guess it will be much faster if you run it on a real server grade box. We have seen load speeds exceeding 1 million rows per second when we use the plain concurrent hash maps as a backing store. But as always, your mileage may vary, and I guess the most important factor is how you have configured and implemented your Hazelcast grid. So what about business model? We are in process of making an open source version of Speedment, and in that Hazelcast support will be included, of course. Certain functions like transaction support and other features might be available via an enterprise license. The enterprise license also includes service and support. Developer licenses are free because I think that the more people are using our products, the better. So we charge enterprise licenses per node, the same way I believe Hazelcast is doing, so you are not really up to any surprises there. Another thing here is that there will be an open source version for the open source databases, whereas you probably need an enterprise version if you use a closed source database. So, thank you. That was my presentation. That brings me to the end. And I hope I've triggered your interest in the new possibility of keeping Hazelcast maps up to date with an underlying database, regardless of how you do it. Now, if there are any questions, I'll be happy to answer them. The question was, what's the delay between an insert, update, and delete, and the Hazelcast map modification? And we supervise this table, the trigger log table, every 100 milliseconds. So the mean delay is like 50 milliseconds, but you can change that if you want. Maybe you want to supervise it more often or more seldom. You can select that if you want, but typically less than 100 milliseconds is the delay. There. Okay, and there's another question. Which relational database are supported? Yeah, right now we're supporting Oracle, Postgres, MySQL, and MariaDB. and it's not. We do not currently support any NoSQL databases, but we're working on that. It doesn't really do something magic with the underlying database. It's only using standard things. So, for example, Cassandra would be very easy because it has already Java triggers, and you can expect several database types to be supported within a short time frame. Okay, question was, what if you want to clean up Hazelcast cluster and later hook up Speedment later for performance reason? Will it sync up? If you want to clean up, yeah, if you clean the cluster and you hook up Speedment, it will start off. You can select if you want to start with what you have and don't want to load the table and just supervise it. You can do that, and but the normal case it will sync up automatically. So it will start off by assuming that the map is empty. So if it's not empty, then it will start filling it anyhow. But you can control that if you want to. Before you start the framework, you can set that if you want it to sync or if you don't want it to sync up. Next question, what are the biggest tables you can load? We have very big tables. Okay, yeah, of course that depends on the capacity of the Hazelcast data grid. We have used databases with terabytes of data. So, and you can divide the load in several chunks. So it's really up to the backing store, how big tables you can have. And it's also about how long start time you can tolerate. Of course, if you have big tables, it will take longer time to populate it from the beginning. But there is no fundamental limits on how big tables you can have. Question is, in the Hazelcast map, can I use my own custom key instead of the table's primary key? Yeah, you can do that. It's just about overriding the add and remove methods. So perhaps you remember that we calculated the key. If you override the add method, you can derive any key you want and use that. But of course, you have to take care so that you use a unique key and a key that's relevant, of course. But you can generate any key just by overriding the add method in the table manager. So that's possible to do. Okay, next question is, how does it work when the Hazelcast is already pre-populated? Can it insert data asynchronously? Yeah, yes, you can do that, but it's the same answer here. Then you have to override the add method, and then you can do pretty much anything you like. You can insert it in your Hazelcast maps how you want. But from the beginning, it doesn't do it asynchronously. It uses the normal put method. But yes, it's very easy to do it if you want to do it another way. DB24 is a DBMS in your roadmap? No, not really. But if there is a customer with an interest, we certainly will look at it. So if you're using this database and are interested, please contact me and we can have a look at it. As I said, it's not a big thing to have a new database type because it relies on standard functionality in the databases. With the reservation that I'm not really so skilled in this particular database type, but I have had to have a look at it. Is it possible to monitor several different databases? Yes, it is. You can, when you set up this, you use a project, and to that project, you can add as many DBMS as you want. So you can aggregate over, for instance, different types of databases, and that's very good because in some situation, for instance, if your company has procured other companies or technology, you might perhaps have a heterogenic database environment, and then it's good with Speedment and Hazelcast because then it doesn't matter that you have different brands. You have the same API anyhow. So you can monitor many databases if you want. Will there be any features that will not be available in the open source version? Yes, we have to earn money, so somehow we need to carve the chase, or I don't know the proper English expression, but most functions will be in the open source, but there will be some typically, I would say, enterprise grade kind of functionality that will not be in the open source version. And also we have discussed, we have decided to have the commercial databases that are not open source. Then you need a commercial license to use them. So that is the answer for that. Question is, can I write my own Hazelcast serializers and deserializers? And of course you can do that. It's very easy. You only have to override the Hazelcast serializer and deserializers in the generated POJO, and you can write your own. Maybe you don't want to serialize all the fields, or maybe you would like to use your own serialization. Maybe you know something more than the generator does. So for instance, you can shorten down or use lookup tables or something in your deserializing scheme. Then it's very easy. You just override those serialization methods, and they will also be retained between code generations, so they will stay intact. Can a Hazelcast cluster be mapped to multiple DB for scalability reasons? In other words, key 100 goes to DB2, key 1000 goes to DB2. Yes, you can do that. You can do that, but then you have to override the naming of the map, because they will be treated at two different tables or two different databases. But by overriding the add and remove methods, you can make them point to the same Hazelcast map if you want. But maybe I misunderstood the question. Maybe it does. Okay, if you mean the cluster but different maps, it's easy. If you mean the cluster and the same map, you have to override the add and remove methods, but it can be done in either case. For instance, if you do sharding somehow. Next question is, can you use entry processes to update the data in place instead of adding and removing? Yeah, basically no, because somehow you have to understand what the entry processor has to do. And in order to understand what it has to do, you need to know what you already have in your map. But this is something that we actually talked about here, that you might perhaps create a local cache of commonly used POJOs, and then when you see and know what you already have in the map locally in Speedment, you can provide an entry processor, and if you don't, then you have to resort to remove and inserting it. But basically, it's difficult to do because you have to know what you already have in the map, and if you have big maps, then the only thing that knows that it's the Hazelcast map, and then you have to get it from the Hazelcast map in order to construct the dynamic entry processor. So, and that's really not a game, but it's something we have thought about, maybe as a feature in the future. Next question is, do you do proof of concepts? Yes, we do. Of course, if you have a project that you think this would be good, please contact us. Contact sales@speedment.com or contact me directly, and we'll certainly talk about that. Good. That's all the questions, yeah. I'll turn over to you, Andrea.
Thanks so much, Per-Åke. Just wanted to let everyone know that we'll be posting this recorded webinar as well as the slides on hazelcast.com. So you can check that out as a resource and refer back to it. Thank you so much for joining.